At this juncture of our discussion in hematology, we will now proceed with anticoagulants. Alam ko that you already know what are anticoagulants. So just a little bit of review. When we say anticoagulant, anti meaning to inhibit. Coagu represents clot formation. Ant meaning an agent. Therefore, when we say anticoagulant, it is an agent that will inhibit the clot formation of our blood. Alam naman natin that when blood is taken out of our body, it will normally clot. Therefore, in order to prevent clot formation of our blood, we will use anticoagulants. Now, ganito. There are a lot of anticoagulants available in the market. So, it's not only EDTA that is available. Marami pang iba. We have citrate, oxalate, heparin, fluoride. So, those are but just a few. So, at this discussion, we will be discussing the different properties of our anticoagulants, their actions, and the different tests which these anticoagulants are used for. Okay. Yan, ano yan? That is a purple tube. Ito naman, micro-containers, color-coded. And these are color-coded tubes. Therefore, tubes used in the laboratory are color-coded. Alam natin yon. And each color represents particular anticoagulant present. So, in the different tests, dapat appropriate yung colored tubes na ginagamit natin. So, when we say anticoagulants are used in the laboratory to examine whole blood. Take note, to examine whole blood. We know that our anticoagulant will prevent clotting of our blood. So, it makes our blood fluid in vitro. So, when we use anticoagulant, we will be able to isolate our red blood cells, our white blood cells, and even our platelets. Kasi diba, for example, in hema we observe for the properties of our red blood cells. We also observe for the properties of our white blood cells and for our platelets. If our blood is clotted, will we be able to isolate our red blood cells? Hindi na, kasi nag-clot na yung blood. Will we be able to isolate our WBCs? Might be if the buffy coat is available. Will we be able to isolate our platelets? Mas lalong hindi. Kasi 'di ba, platelets are responsible for clotting. So therefore, kung nag-clot na ang ating blood, wala na rin dyan si platelet, na-consume na siya during clot formation. So if we want to observe our individual cells, dapat whole blood yung ating blood in liquid form or in fluid form. So that's why we use anticoagulants. Our anticoagulants preserve various analytes and cellular elements and morphology prior to testing. Therefore, our anticoagulants pala have the capacity to stabilize our blood even when taken out of our system. Diba normally, kung walang anticoagulant, ang ating blood, when taken out of our system, it will clot. And then, consequently, it will start to disintegrate. But, with the help of our anticoagulants, the morphology of our cells will be preserved for some time. So, therefore, kahit pa medyo delayed ang ating testing, still it is possible because our cells are stable. Our cells are preserved. And that is because of the action of our anticoagulants. Our anticoagulants preserve various analytes. So, meron palang mga analytes na pwedeng i-preserve ng ating anticoagulants. Example, our glucose. So, for example, if we want to study our glucose, we may also use anticoagulants. But generally, commonly in chemistry, hindi tayo gumagamit ng anticoagulated blood. Kasi medyo mahal kapag gumagamit ng anticoagulant. So, kaya baka magtaka kayo in chemistry, yung ginagamit natin red top. But if we really want to study glucose studies in cells, we may use anticoagulant. And later, you will know what that anticoagulant is. Okay. So, for this discussion, gaya ng sabi ko, we will be discussing the different actions of our anticoagulants. Another, the different tests which these anticoagulants are used for, and additional notes about our anticoagulant. So, our first anticoagulant is oxalate. Tanong! Yan. What is the action of our oxalate? Do you know? Okay, the action of our oxalate, it combines with calcium to form an insoluble complex or salt. Take note, it combines with calcium to form an insoluble complex or salt. Therefore, the oxalate, when present as an anticoagulant, it will readily bind to your calcium. And when it binds to your calcium, it forms a salt. And that is your calcium oxalate. So, tanong, ma'am, bakit of all calcium yung binabind ng ating anticoagulant na si oxalate? Well, basically, calcium kasi is a cofactor during clot formation. So, therefore, if calcium is present, coagulation is promoted. So, kung wala si calcium, wala ring clot formation na mangyayari. Bakit? Kasi once again, itong sa ating calcium, ginagamit siya as cofactor during clot formation. So the action of our oxalate is to combine with calcium to form an insoluble complex or salt. So do not forget ha, oxalate, paki-highlight, paki-underline, paki-box, paki-asterisk, paki-check. That oxalate binds with calcium to form an insoluble complexes or salt. Okay. So, additional notes. Oxalate, there are actually various forms of oxalate available. The first is potassium oxalate. And the other is ammonium oxalate. Ito yung ginagamit nila before, potassium oxalate alone and ammonium oxalate alone. However, they found out that the use of these anticoagulants, potassium oxalate and ammonium oxalate, can cause distortions on our cells. So, magiging erroneous na kung na-distort na ang ating cells. Okay, what is that particular distortion? Pure potassium kasi, it can cause shrinkage of our RBCs and it can promote disintegration of our WBCs. So, when we use oxalate as our potassium oxalate as our anticoagulant, pwedeng makalead to erroneous result. Diba? Bakit? Kasi nga, it can destroy our WBCs and it can also promote shrinkage of our RBCs. So, magiging false na, inaccurate na ang ating mga results kasi nga distorted na ang ating mga cells. On the other hand, ammonium oxalate naman, it can cause swelling of our RBCs. So, kanina, kay potassium oxalate, shrinkage of our RBCs, ammonium oxalate naman can cause swelling of our RBCs. Do you think potassium oxalate and ammonium oxalate are candidate for being good anticoagulants used for hema? Siyempre, hindi na. Kasi nga, diba, it can distort the morphology of our cells. So, that is why they come up with the third form of our oxalate. And this third form of our oxalate is, anong tawag dyan, is the solution to their problem regarding potassium oxalate and ammonium oxalate. And the third form of oxalate is what we call as double oxalate. So, bakit siya tinawag na double oxalate? Double oxalate was discovered by Paul Heller's. Kaya it was also named after him, Paul Heller's oxalate. Now, this double oxalate is a combination of ammonium and potassium. Maalala ninyo kanina, 'di ba? Potassium can cause shrinkage of our RBCs. Ammonium naman can cause swelling of our RBCs. Therefore, the two are combined together to neutralize the action of each other. So, kung si potassium, it can cause shrinkage, si ammonium can cause swelling. So, when the two are mixed together, there is a neutralization. So, hindi na mag-swell at hindi na rin mag-shrink. So, that is why, kaya pala siya tinawag na double oxalate because it is a combination of ammonium and potassium oxalate. So, the double oxalate has the ratio of ammonium to potassium 3:2. 3 parts for ammonium and 2 parts for potassium. So, at this ratio, 3:2, our double oxalate is in balanced form. It prevents shrinkage of our RBCs. It also prevents swelling of our RBCs. So, do not forget the 3 forms of our oxalate. Again, potassium oxalate, ammonium oxalate, and the third one, which is preferred, the double oxalate, a combination of ammonium oxalate and potassium oxalate with a ratio of 3:2. 3 parts for ammonium and 2 parts for potassium. Okay, para saan ginagamit si oxalate? Oxalate is best and ideal for ESR, Winthrop method. So, when we say ESR, it is erythrocyte sedimentation rate. So, if we are going to have a test about erythrocyte sedimentation rate, and the method that we are going to employ is the Winthrop method, dapat yung gagamitin nating anticoagulant is oxalate. Okay, what is the color of oxalate? The color of the stopper, the tube of oxalate, it is color gray. Gray ang ating oxalate. Okay, so naintindihan? So, do not forget, the first anticoagulant is oxalate. Okay, the next anticoagulant is EDTA. Alam ko, kilala nyo na ito si EDTA. Sikat na sikat si EDTA sa atin. What is EDTA, by the way? EDTA is, very good, ethylene diamine tetraacetic acid. Okay guys, take note, hindi dapat siya binabasa as EDTA. It must be EDTA. And again, pabalik-balik na lang, pero sige lang, para mas ma-remember, what is the color of the stopper of our EDTA tube? Very well, lavender or purple. So, kapag nakakakita tayo ng lavender top or purple top, alam natin that the anticoagulant present is EDTA. Okay, so yan. We have a tube there, a purple top tube. So, what is the action of our EDTA? Alam natin si EDTA. So, dapat alam din natin kung ano yung action ni EDTA. EDTA will, yes, very good. Our EDTA chelates calcium. O, pansin ninyo, calcium na naman ang binabind ni EDTA. Kasi nga, gaya ng sabi ko, calcium will promote clot formation. So, without calcium, clot will not be formed. So, for our EDTA, its action will chelate calcium. When we say chelation, it is binding with a metal. So, kapag EDTA ang ating anticoagulant, the proper term that we must use is chelation. Chelation of calcium. Kasi it is binding of our EDTA, metallic binding of our EDTA with calcium. So, yan. It binds with calcium ions. But again, do not forget that when we speak of the action of our EDTA, it must be chelation of calcium. So, do not forget that. Okay. The optimal concentration of our EDTA. So, dapat pala, when used in the laboratory as anticoagulant, there must be appropriate concentration of our EDTA. Kasi beyond that, it can already cause distortion or destruction of our cells. So the optimal concentration of our EDTA when used as anticoagulant is 1.5 mg per ml of blood. So yung ating mga tube, 'di ba, yung capacity niyan is 2 ml. So, the optimal concentration is 1.5 mg per ml. Therefore, yung nasa ating mga tubes na 2 ml ang capacity, yung EDTA na laman dyan ay 3 mg. So, do not forget that the optimal concentration of our EDTA is 1.5 mg per ml of blood. Beyond that, greater than 1.5 or less than 1.5, there will be changes that will occur on our blood. Okay. Continuing. Our EDTA, it is recommended by CLSI because, so diba, the very most common anticoagulant that is used particularly in hematology section is EDTA. So, the following are the reasons or the advantages kung bakit EDTA ang ginagamit particularly sa hema. Firstly, because it preserves cellular morphology. Take note, preserves cellular morphology. So, nagiging stable ang ating red blood cells. Nagiging stable rin ang ating white blood cells at ang ating platelet even when taken out of our system. So, with the use of our EDTA, hindi basta-basta nagdi-disintegrate ang ating cells. Na-preserve kung ano yung shape ng ating cells, na-preserve kung ano yung size ng ating cells. So, kaya pala, maganda gamitin si EDTA. Another, it prevents platelet aggregation. When we say platelet aggregation, it is clumping of platelets together. So, with the use of our EDTA, our platelets will not clump together. So, kasi pag clumped ang ating platelets, hindi natin sila ma-observe. Kasi nga, clumped sila together diba? Paano natin ma-observe kung clumped sila? So, with the use of our EDTA, our platelets cannot clump together. So, kaya we can observe them individually. Another, it is excellent for cell counting. Malamang maganda ito for cell counting kasi nga the morphology of our cells are being preserved. So, kung maganda ang ating cells, madali lang siyang bilangin. Kung okay ang shape ni cells, madali rin siyang bilangin. So, kaya it is excellent for cell counting. And lastly, it is ideal for blood smear preparation. Bakit siya ideal for blood smear preparation? Kasi, blood smears are stable within 2 to 3 hours. Therefore, kapag gumagamit daw tayo ng blood na merong EDTA, pwede daw tayong makagawa ng smear within 2 to 3 hours after collection. So, 'di ba, if there may be delay in our testing, it cannot cause major changes kasi nga our cells are stable within 2 to 3 hours when used with or when mixed with EDTA. So again, these are the various reasons kung bakit recommended ang EDTA by CLSI, particularly for hematology section. However, syempre, EDTA also has a disadvantage kasi hindi naman lahat perfect. The very main disadvantage of our EDTA is that it can cause shrinkage of our cells when used excessively. So, kung mas maraming anticoagulant than our blood, it can cause shrinkage. Maalala ninyo yung explanation natin last time? Yung less blood, more anticoagulant? Diba, we said na it can cause shrinkage. Bakit nga it can cause shrinkage? Kasi, diba, our anticoagulant is excessive. Maraming anticoagulant ang nasa labas ng ating red blood cells. So, kung mas maraming anticoagulant ang nasa labas, mas maraming solute. Kung mas maraming solute, lalabas ang water galing kay red blood cells. Bakit lalabas ang water galing kay red blood cells? Lalabas siya kasi kailangan niya i-dissolve yung excessive solute na nasa labas ng red blood cells. So, kung lalabas ang water, syempre, our cells will shrink. So, kaya, when EDTA is used excessively, shrinkage will occur. Pag mag-shrink ang ating cells, what will be? Uy! Nahuli! Sorry! Yun. Okay. So, when our cells shrink, what will happen? Yes, liliit ang ating cells. Kung liliit ang ating cells, accurate pa ba ang result na ma-form natin? Hindi na, kasi meron ang changes sa ating cells. So, yun lang yung number 1 na disadvantage ng ating EDTA. But generally, EDTA is ideal for hematology. Yun nga lang, there must be an optimal concentration. And dapat properly filled ang ating tube. Pag sa ating tube, indicated na 2 ml dapat ang amount of blood, dapat 2 ml talaga ang nasa tube natin. Kasi pag konti lang ang blood, mas maraming anticoagulant, again, it can cause shrinkage of our cells. Okay, so there are 2 forms of EDTA. First, we have sequestrine. Sequestrine is the liquid form of our EDTA, and it is dipotassium or tripotassium. So, pag sinabi nating sequestrine, it is the liquid form of your EDTA, dipotassium and tripotassium. So, kung titignan ninyo yung mga EDTA na nasa kits ninyo, it is in liquid form. And kung basahin ninyo, may nakalagay dyan K2 or kung hindi naman K2, K3 EDTA. So, that is dipotassium EDTA or tripotassium EDTA. The other form of our EDTA is versine. Pag sinabi naman nating versine, this is the solid form, yung powder form of our EDTA. And our versine is sodium EDTA. So, do not forget, sequestrine, liquid, dipotassium or tripotassium. Versine, solid form, the powder form, our sodium EDTA. So, do not forget the 2 forms of our EDTA. So, saan ba maganda gamitin si EDTA? What particular test maganda gamitin si EDTA? EDTA particularly is used for routine hematology. For example, CBC. Have you tried submitting yourselves to CBC testing. Mapansin ninyo kung ano yung tube na ginagamit ng medtech during collection. Kung mapansin ninyo, if you're that observant enough, yung tube na ginagamit ng medtech kapag magko-collect ng blood for CBC is lavender top. Kasi nga, again, I repeat, EDTA is ideal for hematology. And another, platelet counting. Diba, alam naman natin, EDTA prevents clumping of our platelets or aggregation of our platelets. So, therefore, maganda at pwede siyang gamitin for platelet counting kasi hindi sila nagka-clump together. Okay, so that is for our EDTA. Do not forget, EDTA, the most common anticoagulant that we use, particularly in hematology. Once again, the action of our EDTA is to chelate calcium, chelation of calcium ions. And EDTA is best and ideal for routine hematology and platelet counting. So do not forget that. Our next anticoagulant is citrate. Yan, I have a picture there of citrate. Sige, saan dyan si citrate? Yan, I bet alam nyo kung saan dyan si citrate. So, that is our citrate tube. Color, light blue. Do not forget, oxalate, gray. EDTA, lavender. Citrate, light blue. So, huwag kalimutan. Our citrate, what is the action of our citrate, by the way? If our oxalate binds with calcium to form insoluble complex, if our EDTA chelates calcium, ano naman yung action ng ating citrate? Well, basically, our citrate will bind with calcium to form soluble complex or non-ionized form. Take note, paki-highlight, paki-underline, paki-check, paki-asterisk, paki-box. Soluble complex or non-ionized form. Bakit ko yan pina-highlight? Kasi maalala ninyo, ano nga ulit yung action ng oxalate? It will bind with calcium to form insoluble complex. Our citrate will bind with calcium to form soluble complex. So, please do not be mistaken about this. Huwag niyong pagpalitin yung dalawa. Oxalate, insoluble complex. Citrate, soluble complex. So, once again, your citrate will bind with calcium to form soluble complex or non-ionized form. So, wag kalimutan na, paki-highlight lang. Additional notes for our citrate. Our citrate actually has two forms. The two forms of our citrate differs in the concentration. So, what are these two forms? First is the 3.2% or 0.109 molar sodium citrate, and the other is 3.85% or 0.129 molar sodium citrate. So these are the two citrates available in the market, 3.2% and the 3.85% concentration. So ano naman yung different tests which citrate is particularly used for? Si ano daw? Well, citrate basically is best and ideal for coagulation studies. So, if we want to observe coagulation in our system, we just have to use our light blue top. So, hindi pwedeng gamitin si EDTA. Hindi pwedeng gamitin si oxalate. Kailangan pag coagulation studies, what will be the tube that we're going to use? Of course, citrate. Please do not forget that for coagulation studies, we're going to use citrate. Another, during blood transfusion. Kasi yung nasa ating blood bags na anticoagulant is citrate. So, meron palang citrate yung ating mga blood bags. Kaya pala, fluid pa rin yung blood na nasa ating blood bags. That is because of the presence of your citrate. And another, ESR, but the method for this time is Westergren. So please do not interchange the information. Oxalate, insoluble complex, used for ESR, Weintraub method. Do not forget how Weintraub method. Citrate, soluble complex, used for ESR, Westergren method. So, please do not forget to not interchange ESR, Westergren ang sa ating citrate. So, yun ang para sa ating citrate. Again, the action of our citrate is it binds with calcium to form soluble complex. And it has two forms, the 3.2% and the 3.85%. And our citrate is best for coagulation studies, blood transfusion, and ESR Westergren. Okay, our last anticoagulant is our heparin. Heparin, again, ano nga itong heparin? Yes, I know, naaalala nyo pa that heparin is a naturally occurring anticoagulant. Again, just a little bit of review. Saan ginagawa si heparin? What particular organ produces heparin? Okay, it is the liver. So, kaya nga siya heparin. Hepa pertains to the liver. So, it is our liver that produces heparin. And once again, kaya pala liquid ang ating blood inside our body because there is the presence of heparin, a naturally occurring anticoagulant. Our heparin is an acid mucopolysaccharide. So, ito yung nature ng ating heparin, acid mucopolysaccharide. And once again, it is our naturally occurring anticoagulant. And if EDTA has an optimal concentration of 1.5 milligrams per ml, our heparin also has an optimal concentration when used as an anticoagulant. And it must be 15 per 20 units, 15 to 20 units per ml of our blood. So that is the concentration of our heparin, 15 to 20 units per ml of blood. Okay, heparin is a naturally occurring anticoagulant. Yes, it may be the best anticoagulant that is available kasi nga 'di ba naturally occurring siya. However, you must take note that the anticoagulants available in the market are already commercialized. So, hindi siya yung naturally occurring anticoagulant. And since it is already commercialized, there are various disadvantages that we may encounter when used with heparin. Heparin is not satisfactory for morphologic studies. So, hindi siya pwedeng gamitin kapag gagawa tayo ng blood smear, for example. Kasi nga, it cannot preserve the morphology of our cells. Kung si EDTA, stable ang morphology ng ating blood cells within 2 to 3 hours, heparin naman, it cannot preserve the morphology of our cells. So, kaya, hindi siya pwedeng gamitin na anticoagulant kung gagawa tayo ng smear at i-observe natin yung cells in terms of their shape ba or size ba. Kasi tendencies are, and we're going to use heparin as our anticoagulant, there are already destructions of our cells when used ang heparin. So, kaya, hindi siya magandang gamitin for morphologic studies. Another also, it can cause errors in automated cell counting. So, yun nga, gaya ng sabi natin, our heparin rather, is not best for morphologic studies. It can cause distortions of our cells. So, kaya when we use it for automated cell counting, there might be errors already. Kasi nga, hindi na maganda yung cells with the use of heparin. Kung ipaparead mo pa yan, pangit yung reading ng ating machine. Okay, so what is the action of our heparin? The action of our heparin, the heparin found inside our body, and the heparin that is available commercially has the same action. And what is that? That is to inhibit thrombin. Baka nagtaka kayo, ma'am, kanina, oxalate, calcium, EDTA, calcium, citrate, calcium. Bakit po ang heparin, thrombin naman sa kanya? Well, basically, only God really knows the affinity, kung bakit highly attractive ang ating heparin sa kay thrombin. But, thrombin, ito kasi si thrombin, ito yung tinatawag nating factor 2 sa coagulation. This thrombin will act upon your fibrinogen to promote clotting. So, if there is the presence of your fibrinogen, fibrinogen will be converted to fibrin. When fibrin is formed, there will be clot formation. So, without thrombin, will there be conversion of fibrinogen to fibrin? Wala. Kung walang conversion ng fibrinogen to fibrin, meron bang fibrin na mabuo? Wala pa rin. Kung walang fibrin na mabuo, meron bang clot formation? Wala pa rin. Diba? So, that is why the action of your heparin, it inhibits thrombin. So, without the presence of thrombin, there will be no clot formation. Okay. So, what tests heparin is best for? Well, basically, you have to know that heparin is best and ideal for osmotic fragility tests. Later, in our discussion sa mga different tests, different hematology tests, malalaman nyo kung ano yung osmotic fragility test. But please do remember, always remember, that the best and ideal anticoagulant for osmotic fragility test is our heparin. Another is our arterial blood gas measurement. Arterial blood gas measurement. What is the method of collection that we use for ABG measurement? Very good. Arterial puncture. So, if we want to measure pala arterial blood gas, hindi pala dapat diretsong kukuha tayo ng dugo. Dapat pala yung ating syringe na ginagamit or yung ating tube is dapat heparinized. Kasi your heparin, it can preserve or it can maintain the viability of your cells when taken out of your system. And thirdly, heparin is used for exchange transfusion. Okay, ano yung exchange transfusion na tinatawag nila? Exchange transfusion, Well, basically, when you want to have an exchange transfusion, you want to have an exchange of your blood inside your body. So, papalitan yung blood on your system. Paano nangyayari yon? Will you take out all of your blood? Tapos, papalitan ng bago? Siyempre, hindi yun ganun, no? Baka kung maubusan kayo ng blood, patay kayo niyan. Exchange transfusion is like, ganito yan. Merong blood bag. Yung blood bag, imagine niyo lang muna, imagine. Yung blood bag, yan yung the new blood that will be transfused to you. On the other end is a waste bag. Yung waste bag, lalagyan yon ng inyong old blood or yung blood na gusto nyong tanggalin para palitan ng bago. So, paano nangyayari yon? As there is infusion of your blood, meron ding tawag yan, excretion of your blood on the other end. So, kunwari, dito sa left side, papasok yung bagong dugo. Dito sa right side, lalabas yung inyong lumang dugo or yung original blood ninyo. So, that is the exchange transfusion. Exchange kasi, literally, you are changing the content of your blood. So, a new blood is infused and your original blood is taken out of your system. So, syempre, that is exchange transfusion. Magpapapasok kayo ng bagong blood sa inyong system. Dapat talaga na yung bagong blood na papasok sa inyo has an anticoagulant that is the same with that of your original blood. Yung original blood ninyo, ano yung anticoagulant? Heparin. So, dapat yung bagong blood na papasok sa inyo, heparin din ang laman as anticoagulant. So, do not forget, heparin is best for osmotic fragility test, arterial blood gas measurement, and exchange transfusion. And do not forget, the action of your heparin is to inhibit thrombin. And the optimal concentration of your heparin is 15 to 20 units per ml of our blood. So do not forget our naturally occurring anticoagulant, which is heparin. Okay, our last anticoagulant, the last anticoagulant available in the market for use is our fluoride. Okay, ano itong fluoride, ma'am? Saan ito ginagamit si fluoride? Okay pala, review ulit muna tayo. Review. The color of oxalate is gray. The color of EDTA is lavender. The color of citrate is light blue. The color of heparin is green. Okay, review. What anticoagulant will bind with calcium to form soluble complex? It is our citrate. Ano naman yung anticoagulant that will chelate calcium? Very good. EDTA. Ano naman yung anticoagulant na will inhibit thrombin? Very good. Heparin. And ano naman yung anticoagulant that will bind calcium to form insoluble complex? Very good. Oxalate. So, do not forget ha. Okay. For our fluoride. The action of our fluoride is to form weakly dissociated calcium components. So, do not forget, it will bind with calcium. But, the binding of calcium is weakly dissociated components. So, mga weak salts only. Kung si oxalate, insoluble salts, si citrate, soluble salts, Si fluoride naman, weakly dissociated calcium salt. So, mga weak bindings with calcium. Pure fluoride is both an anticoagulant and preservative. So, it can prevent clotting of your blood, and at the same time, it can preserve a particular analyte. And there are two forms of fluoride available. First is sodium fluoride, and the other is potassium fluoride. So, ito yung forms ng fluoride available in the market. Sodium fluoride and potassium fluoride. And your fluoride is best and ideal for glucose studies. Uy! It is ideal and best for glucose studies. Therefore, maalala ninyo, fluoride is both anticoagulant and preservative. Therefore, with the use of your fluoride, your glucose is being preserved. Very good. So, therefore, pag andyan pala si fluoride, your glucose will not be consumed. Mapre-preserve si glucose. Paano? Paano nangyari yun? Well, basically, your fluoride will inhibit enolase. So, enolase is an enzyme that will promote consumption of your glucose. So, without this enolase, your glucose will not be consumed. Your glucose will not be used for energy making. So, ma-preserve si glucose kasi na-inhibit si enolase. So, again, kaya pala siya tinawag na anticoagulant and preservative at the same time because anticoagulant because it can make our blood in liquid form, and secondly, preservative because it will preserve glucose. And paano? By inhibiting enolase. So, if you really want to study glucose, mga glycolytic studies, glucose studies, now without disturbance of the glucose itself, you may use fluoride as your anticoagulant. So, do not forget, fluoride, again, the action, it forms weakly dissociated components with calcium. So, mga weak bindings with calcium. And do not forget that, pabalik-balik na lang, para hindi makalimutan, that fluoride is best for glucose studies. Kasi bakit? Yes, it will inhibit our enolase. So, yun ang action ng ating fluoride as anticoagulant. So, do not forget our anticoagulants that we use commonly in the laboratory. We have oxalate, color gray, EDTA, color purple or lavender, citrate, light blue, heparin, green, and fluoride gray. So, do not forget our anticoagulants that we use in the laboratory. So, you have to take note that evacuated tubes are filled with pre-measured anticoagulants. So, yung anticoagulants na andyan, pre-measured. When we say pre-measured, there is already an exact amount of anticoagulants. So, dapat yung amount also ng ating blood ay exact. Hindi pwedeng kulang, hindi rin pwedeng sobra. Again, what will happen kapag there is more blood, less anticoagulant? Yes, the blood will clot. And what will happen naman if there is less blood, more anticoagulant, particularly on our EDTA? It will cause, yes, shrinkage of our RBCs. So, kaya, during completion, hindi ako tumatanggap ng underfilled. Hindi rin ako tumatanggap ng overfilled. That is because you have to maintain the proper ratio of your blood and anticoagulant when you transfer blood to your tubes. Do not forget the different actions of our anticoagulants that are available in the market. Again, lastly, your anticoagulants are agents that will inhibit or prevent clot formation. That is why, even when taken out of our body, our blood remains in liquid form. And that is because of the action of our anticoagulants.